Hey there, y'all. Today we're going to look at the review for Unit 1. Remember, Unit 1 was on quantities and expressions. And so what we're going to do is we're going to do a section by section, talking about the major key points of each section and things to remember for that first unit test. And so in section 1.1, we talk about precision and significant digits. And so if you're looking at your notes, key things to remember is that precision is the level of detail of a measure. And when we talk about a unit being more precise, remember looking at the significant digits, right? And we also look at the units themselves. And so, for example, like the examples here, we have 5.7 meters or 568 centimeters. The centimeters is a more precise unit, and so it is more precise. When we look at 9 inches to 1 foot, again, inch is a smaller unit compared to feet, and so inches are more precise. And so remember that if we have different units, the best thing to do, convert them to the same, and we'll see which one is more precise in the end. Remember with significant digits, remember these are digits that carry meaning about the precision of the measurement. And we had 5 cases or 5 rules that we dealt with. And so remember that the first case is that all non-zero digits are significant. And then we had 4 cases that dealt with the zeros. Remember that case 2 and case 3, we're talking about zeros that will be significant in it. So any zeros between significant digits are significant. And then case 3, zeros to the right of the decimal point and at the end of the number are significant. So like the zeros back here. But zeros to the left of the first non-zero number are not significant. So all these zeros here, not significant. And zeros at the end of the number without a decimal point are assumed not significant as well. So if we have a large number with some zeros at the end, again, talking about not a decimal number, but like a big number, like millions and billions, and all those zeros behind are not significant. And remember, we did operations on significant digits, and we had 2 rules for that. If you're dealing with addition and subtraction, remember that we have to round our answer to the least significant digit of the least precise measure. And so remember, the least precise measure is the one with less significant digits. And so like here, the 3.4 is less significant, right? And then, sorry, the least precise would be the one that has less place value, right? And then the least significant value, so like here, we round to the 7.9. If we're doing multiplication and division, remember we have no more significant digits than the least precise measure. And so here, this had 2 significant digits, and our final answer could only have 2 significant digits as well. And then we looked at some operations dealing with like perimeter. Remember, perimeter is adding up all the sides of that figure. And remember, area is length times width for a rectangle. And so that's what we're looking at there in section 1. So as we look at 1.2, 1.2 is on dimensional analysis. And remember that our standard here was to be able to convert between metric measurements and customary measurements. This is where you had your reference chart with all of those conversions from like inches to feet or miles to yards, all those conversions on your chart. And so remember, dimensional analysis allows us to solve problems involving measurements using conversion factors. And so like the example here, if we want to convert pints to liters, remember we start with our pints, we use our conversion factor, and we want them to cancel by 1 being in the numerator and 1 being in the denominator. Remember, they've got to be across from each other to be able to cancel. And so all the examples here on converting those. And remember, when we deal with rates, remember that's units over units, right? So like kilometers per hour in this example to A. If I need to cancel the kilometers and change it to something else, I'm going to get those kilometers in the denominator to get them to cancel. Remember, top, bottom, numerator, denominator, right? And then same thing with the hours. But the hours are already in the denominator, so I need to cancel them by being in the numerator. And so we get those to cancel that way. And we see the conversion here to miles per minute. And so dimensional analysis could also be used to give us areas. And remember that if I have a square unit, that means that I'm going to have to cancel that unit twice. And so I have to cancel the feet once and convert to meters, and cancel the feet a second time and get it to meters. And that will give me my meters squared for the final unit. And so that is dimensional analysis in section 1.2. All right, so let's look at 1.3 in the real number system. In this section, we looked at how to classify real numbers and determine if a set is closed under an operation. And so in 1.3, remember that we talked about the different sets of numbers: natural, whole, integer, rational, irrational, and real. And some of the things there, remember, are that rational numbers have to be able to be written as a fraction, right? It could be a decimal, but it has to be able to convert to a fraction. Irrational numbers are going to be decimals that never stop and never repeat, like pi or the square root of 2. Remember, integers, look at this set. There's no fractions there, right? But we have got negative numbers, we got positive numbers. Whole numbers, 0, and then counting up, 1, 2, 3, 4, 5. And our natural numbers just start at 1. 1, 2, 3, 4, 5. Don't include that 0. Remember, and real numbers are any number that has a location on the number line. Remember, we talked about the sets here, and I don't know why this is blank, but we'll get that refilled in. We also talked about the diagram here on how to compare rationals and irrationals and how the sets all interplay with each other. Then we talked about closure. Remember, closure means that a set of numbers is closed when an operation, if the result of the operation on any two numbers in that set is also a number in that set. So we looked at the example of -1, 0, and 1. And we said that, okay, if we add all these numbers together in pairs, right, is there a time when it will give me an answer that is not one of these three numbers? And so we see that -1 plus -1 is -2. So that's not one of these three numbers, so this set would not be closed for addition. But we also did it with multiplication. We saw that if I multiply all these different pairings together, then we saw that -1, 0, and 1 is closed under multiplication. Okay? And we talked about other sets, right? And so again, this part, again, don't know why it's blank here, but we'll get it filled back out. Remember that we talked about like real numbers, right? Real numbers are closed for addition because I can add any two real numbers and still get a real number. Same for subtraction and multiplication. Remember for division, we talked about if I divide by 0, that does affect closure, and that affects it for real numbers and rational numbers. You can't divide by 0 in irrationals because 0 is not irrational, so irrationals, but they're still not closed there. And then integers also have the issue of 0 being there and not being closed, but also you can't divide certain integers anyways. So that is section 3. All right, so let's look at section 4. That is on radicals and rational exponents. And in this section, we looked at simplifying expressions that have radical or rational exponent notation. And so one thing I want to remind you of when we talk about these radicals, where things go, right? We talked about that the number in the hook of the radical up here is called the index. The number inside is called the radicand. And then we could have a power out back. And we will look at some of these values, right? And we talked about perfect square numbers, and we have other powers that will work, right? We could talk about perfect cubes, 1 cubed and 2 cubed and 3 and so on. But we talked about how to estimate. That's not going to be important for the test. But we do definitely want to know how we can convert from, say, 64 to the 1/3 power. Remember that the denominator becomes the index. The base of the exponent becomes the radicand, the part inside the radical. And if I had a numerator other than 1, like we have in the examples down here, remember that will become the power out back. And so I can take the cube root of 125. And so what times itself gives me 125? Well, 5 times 5 times 5. Because 5 times 5 is 25, and 25 times 5 is 125. And then it told me to square that number, so 5 squared is 25. Okay? So remember what goes where with those problems. Remember that we also talked about the properties of exponents and how we can do product of powers or quotient of powers, power of a power, negative exponent. All these properties are properties that you should have seen in 8th grade math. And again, this is a review for the most part, but pay attention to these properties. Remember that if I'm doing product of powers, we're going to add those powers. Quotient, we're going to subtract those powers. If I've got parentheses and that power is going inside, no matter if it's multiplication or division, that power is going to go to everything that's in there. Power over power, those powers are going to multiply. And negative exponent means I'm going to flip where that piece is, either from the numerator to the denominator. And so as we look at the bottom part of this section, remember we looked at how we can substitute values in to also be able to solve for. And again, using our exponent properties to convert to radicals to be able to simplify these problems. So let's look at 1.5 on evaluating expressions. And in this section, our key goal was to be able to evaluate and interpret expressions. And so remember that an expression is a mathematical phrase that contains operations, numbers, and or variables. But remember, it cannot have an equal sign, because if it has an equal sign, it is an equation, not an expression. A numerical expression contains only numbers and operations, while an algebraic expression contains at least one variable. Remember your order of operations, parentheses, exponents, multiplication, division from left to right, and then addition, subtraction from left to right. And so as we evaluate expressions, remember that we can take the value of the variable, so a equal to 4 here, substitute in everywhere we see the a, and then do our order of operations to be able to simplify this expression. Okay, so make sure you pay attention to your steps. What is going to touch what? Okay, and again, if we have multiple variables, we plug in appropriately for each variable. And if we're doing word problems, remember that we will plug in, again, still where things are appropriate for where they need to go. And so remember to evaluate expressions, substitute your values in, and then do the order of operations. That's section 1.5. As we look at 1.6, we're going to look at simplifying expressions. And remember, to simplify expressions, we are going to use our properties to be able to first identify like terms, and then using our properties be able to combine those like terms through addition or subtraction. And so when we look at problems like these, we see that 4a and 6a are like terms, and we can add those together and get 10a. The 13 doesn't combine with this, so it's 10a plus 13, and that is your final answer. Don't touch anything else in that problem, right? Or if we've got a number out front, we can distribute. And remember, you can multiply a number to a variable, or a number to a variable with a number in front of it, right? So like 4 times 2x, and we get 8x, right? So we can do that with these problems. And remember, we'll combine like terms. And then as we talked in section 6 and section 7, which we're getting to next, remember, we want to be able to substitute our values in, use our order of operations to simplify these expressions and get it down to a final value. And remember that word problems require what? Word answers. Okay? And so that's section 6. Again, remember that be able to plug in and simplify those expressions down to a final value. The last thing we looked at in 1.7 was on writing expressions. And so the goal was to write algebraic expressions to model quantities. And when we looked at this section, section 7, we talked about different words that mean addition, subtraction, multiplication, division. These were the words that first block came up with, and these were the words of fourth block here. And so you can see the two lists if you want to go back and pause the video and see the two lists, and maybe there was something in first block that wasn't on the list for fourth block, and add it to your list, right? But as we talk about section 7, remember, we're trying to find the key words of these problems, find what is the variable, find what's being added or multiplied, and using those words to change those verbal expressions into an algebraic statement, into an algebraic expression. And again, pay attention to what units go where, because that is important in understanding how things will combine together. So as we wrap up Unit 1, the key thing here is understanding how expressions work, how to get through the real number system, and what properties we have to be able to simplify and solve. And so that is the key to this chapter. Understand the different properties, understand the different cases for like significant digits, how to convert units through dimensional analysis, and dealing with radical and rational exponents. And so again, the last thing you're going to need to do is for this video, if there's any questions from this video, if there's any questions from this unit that you're like, hey, we need to go back over this. The only question in the Google form for this video is what questions do you have for the review? And so make sure you submit your questions there. Ask away. Put 50 questions there. If you have 50 questions, put them all in that Google form. And so that's it. I hope you all have a good one, and I'll see you next time.